Thank you for joining this new lecture and this new session. In this session, we are going to talk about denial of service attack from a smart contract perspective. How we're going to see exactly how to perform this kind of attack on a smart contract, but also how to prevent this kind of attack from happening in smart contract. So in the previous lecture, we talked about transaction flooding. This is actually an implementation of denial of service attack on blockchain node transaction perspective. But we also talked about the traditional denial of service attack from the network perspective, where we saw that how an attacker can send a huge amount of requests to a particular server to crash down so that it cannot render a particular web page. So this is a traditional denial of service attack, and we can go over and perform what we call a DDoS attack, that we call distributed denial of service, with the help of botnet. So in this session, we are going to talk about denial of service attack from a smart contract perspective. And we can see here that we have two kind of denial of service attack from smart contracts. So the first one is actually unexpected revert denial of service attack. And here you do not expect a transaction to revert, but it actually does. And the second one is what we call the block gas limit DDoS attack, or DOS attack. So it deals here with gas limit, and here it deals with reverting transaction. And this is actually what we are going to explain in the next slide. So this is actually an illustration of the unexpected revert denial of service attack. So we need to pay attention to that, because it's actually where you have to understand first before getting into the practice. So it's really important to understand that. So let's say we have a bank, okay, a bank powered by smart contract, or a bank has created a smart contract so that investor can put money into that bank. And the bank has actually created a logic inside that smart contract so that if an investor comes and deposits an amount of money that is greater than what was actually there, that investor becomes the most influential investor, and he can have some privileges from the bank. So I'm going to explain what I mean. We have this bank here, and the bank has created a smart contract. And here we have an investor, let's say it's actually Laura, okay? And Laura is going to put 1 ETH into that bank, okay? And once she deposits that 1 ETH into the bank, she becomes the most influential investor, and she can have some privileges from that bank, okay? Because in the smart contract, there were not money inside, okay? It's really important to understand that. Now, we're going to move. We have another investor that is called Paul. And Paul is actually willing to have some privileges from the bank, okay? And once Paul is going to deposit 2 ETH, is going to become the best investor, or the most influential investor, because it is actually greater than what Laura put. So the smart contract, or the logic of the smart contract, is going to give back, monies Laura, so that in the smart contract bank we can have only 2 ETH that represent the Paul investment. So this is really important to understand. This is actually the logic of the smart contract. Once someone deposits more than you, it becomes the most influential investor. He can have all the privileges, and the smart contract logic is going to give back directly Laura's money, because the money that Paul's put into the smart contract is greater than 1 ETH. So now we're going to move for you to understand exactly how it happened. This is actually the same thing. And we have Jason. Jason is going to put 3 ETH. What's going to happen is that Jason is going to become the most influential, investor. He's going to have all the privileges that Paul had, and the bank smart contract is going to give back, the Paul's money, because 3 ETH is greater than 2 ETH. This is actually the logic. When someone deposits an amount of money that is greater than you, it becomes the current, most influential investor, and the bank is actually going to give you back, your money. So let's see how we can actually break this game, how we can break this logic of that smart contract, so that even if, someone deposits a greater amount of money than me, he cannot become the most influential investor. So this is what we are going to see now. And to do that, we have Paul. So Paul is going to try to break this game, okay? And, Paul has deposited 2 ETH. So that's what you have to know. So this Paul is actually a hacker, okay? He's going to break this system. So now what's going to happen is that Paul is going to create a smart contract, and is going to deposit 2 ETH into that smart contract, okay? And once he deposits the money into that smart contract, it's going to use that smart contract to deposit money into this bank smart contract. So it's really important to understand that smart contract can actually interact each other, okay? The smart contract is also like a wallet, okay? So it's going to put 2 ETH in this smart contract, is going to deposit it into the bank smart contract. So it's really important to understand that. And it's going to create what we call a malicious smart contract, okay, that can break that game, so that Jason cannot become the current king. So now Paul is the current king, and we're going to see why he cannot be the current king. And once we come here, Paul has deposited 2 ETH, okay? And, via his malicious smart contract, because it's actually coded a malicious function that cannot receive money. So this smart contract cannot receive money back, okay? This smart contract cannot receive money. That's why it's going to break this game, this smart contract logic, this bank logic. So since it cannot receive any amount of money, even if Jason comes and deposits 3 ETH, it cannot become the most influential investor, because Paul will not receive his money, and he will remain the most influential investor, and will have all the privileges that the bank, gives to the most influential investor. So this is actually how it works, how we can, perform a denial of service attack from a logic of a smart contract. So remember, a smart contract is a piece of code that we deploy into the blockchain. It can be represented as a bank because you can program, a smart contract that actually works like a bank. And you have to know that smart contract can interact each other, because this smart contract, this malicious smart contract that cannot receive money, is actually programmed by Paul, and is going to use it to deposit money, so that this smart contract cannot receive any money. And if this smart contract cannot receive any money, it means that the game has been broken, so that Paul remains the best investor in that bank. And this is how the goal is break. So thank you for listening to me, and see you in the next session, where we are going to program, and we're going to see exactly these 2 smart contracts, how can attack. Thank you. Yeah, thank you for joining this new section, this continuation of the denial of service attack on smart contract. And we saw that how the bank contract is supposed to work, and we saw that the bank contract is working perfectly. And we implemented this strategy, okay? These Alice, Bob, and Laura. So now we're going to write another contract that is called the attacker contract. And this attacker contract is going to try to break this challenge, to break this logic on this bank contract. So as we already know, I've already programmed the smart contract because I don't want to lose too much time. And I'm going to explain this code as I started doing with this first one. And at the end, you are going to have the code listed below so that we can download and try to work and try to break and even add some function. So now we need to create the attacker contract. So this is actually here. So we created the file for that, and that file is called the attacker contract. We click over here, and this is actually this attacker contract. Okay, so we need to understand this contract to be able to try to launch this attack and see if it's going to work. So now let's say this is actually the attacker contract, and as you know, we defined these two things before. Okay, and what we can notice that we actually declare the bank contract here, and we imported this special function trying to become the biggest investor. Okay, so this is the first thing we need to understand and notice. Okay, this is actually the bank contract, because if you want to hack a contract, you need to create a connection to this contract, and you can create a connection by either declaring that contract in your smart contract, victim smart contract, or by declaring a variable that is going to, get the connection done between the victim contract and the, the, the bank contract. Okay, so this is actually how it works. So we've declared this bank contract, and we, declare the function that we want to hack. Okay, the function that will help us to attack this contract in order to break the game. So now this is actually our real hacker contract. So it's not really too much. Okay, it's some line of code. So you can see that we have the first contract is going to be, the first function is going to be the attack function. So the attack function, we are going to pass in the address of the bank, okay, the address of this bank to be able to break the game. So this is how we are going to create the connection. So once the hacker is going to put this, is going to put this bank address here and deploy the contract, what is going to happen is that it's going to create a connection directly to this bank contract. So you need to understand it. And once you're going to try to implement it, you're going to see what I'm explaining. So now we have another line, okay? This line is actually trying to call this function to become the biggest investor in the bank. So this is how it works right now. So the attacker or the hacker is going to click that function, and once it's going to click that function, it's going to trigger that function inside this bank contract, and it's going to deposit an amount of money. But there's one function that is really important to understand here. We know that once Alice deposits 1 Ether, she became the current biggest investor, and now Bob deposited 3 Ether, and he became the current biggest investor. So what happened here? Once Bob became the current biggest investor, the smart contract is transferring back Alice's fund. And here you can see that the hacker has created a fallback function or a receive function that is used to receive money. And what is actually here, they have coded a revert in such a way that this contract cannot receive any money. It means that one is going to be the current biggest investor, okay, and someone else will try to become the current biggest investor too. It will not be able, because this contract will not be able to receive some money back. So this is actually the game, how the game is going to be. So let's take it from this perspective. So this is Alice. She deposited 1 ETH, and then Bob is actually a malicious guy. He's going to create a malicious smart contract and deposit 3 ETH. Now it becomes the king, or it becomes the current biggest investor. But the contract cannot receive the money. But this is a malicious contract. It cannot receive money. Okay, so this is actually the malicious contract from now. And now we have Laura. Laura has, let's say, 5 Ether. She's going to deposit 5 Ether in this case. And these 5 Ethers, even if she deposits 5 Ether, she will not be able to become the current biggest investor in that bank, even if 5 Ether is higher than 3 Ether, because once she's going to click that function, try to become the biggest investor, the smart contract will not be able to refund Bob money, and this is going to break the game. So now we are going to try to, experiment exactly how it works. So now we need to deploy the two contract again. So let's come to the bank contract. No, it's the victim contract. Okay, we are going to deploy the victim contract again and see how we can play with that. So this is actually the bank contract that we know, okay? The contract that handles this function. So we need to deploy it again and see how we can break it. So let's close everything that has been done before. So now we are on the bank contract or the victim contract. We are going to click deploy, and we are going to try to deposit some money. So let's take this example, okay? We are going to take this example over here, this one. Okay, let's come here so that you can understand. So this is actually the example we are going to take now. So focus on this example. Let's focus on this example so that you can understand. So now we've deployed the bank contract, and what we're going to do is that this is Alice, and Alice is going to deposit 1 Ether, and we already saw that. And we come down, we click try to become the biggest investor. Okay, the transaction has been successfully done. Now if we click the current biggest investor, is going to return Alice Ether. So this is the example that we need to follow now. If we click highest amount of money, is going to see 1. Now Bob is going to create, is going to deposit 3 ETH, but is going to do that with the attacker contract. Okay, so now we need to put it like this, and now we are going to come here. We are going to deploy this contract too. Let's come here under attacker contract, and we are going to position ourselves in, let's come in the last account. So the last account represents the hacker contract or the hacker address. Okay, and this is actually the hacker address. So we are going to deploy that address. Okay, this contract. Okay, this contract. So let's click on deploy. The contract has been deployed successfully. Now we can open that instance. Okay, yeah, you can see that it has opened. Now we are going to try to attack this contract, and to be able to attack that contract, we just need to put the address of this bank. Okay, the address of the bank that has been deployed. So to do that, we just come here and copy. This is the bank that we just deployed. So just come here and click copy, Once it is done, you come back here at the ACA contract, because this is actually ACA contract. When you open it, you do Control V. Okay. So what is going to happen is that once I'm going to click on that attack function, that is actually the contract that has been programmed by Bob, a malicious contract that cannot receive money. Bob is going to become the current biggest investors. But since this contract does not receive money back, the game is going to be break. Because if Laura comes with 5 Ethers and try to deposit to become the biggest or the current biggest investor, is not going to work, because this contract will not receive back the money. So I hope you understand the logic. So now we're going to press that button. If you say attack, you say the transaction was not successfully done. Okay? And we're going to try to understand what happened. Okay, we didn't actually precise. So Bob is going to deposit 3 Ether. So this is 3. Okay, that's why the transaction didn't work. So we are going to try to press that button again. And if you click attack, this process I've just explained is going to work. And we're going to see if the transaction is successful. We're going to see a green cross. Okay, let's say attack. You see the transaction has been successfully done. Now we need to check. Okay, need to open this bank instance, and if you try to click on this variable current biggest investor, I'm going to see which address is actually there. You can see this address represents the new address of the ACA. So this address represents this one, okay, this last one, okay. So this is the hacker. The hacker is actually the current biggest investor, so Bob, with this malicious contract. So now if you click highest, you can see 3, or these 3 Ether that Bob has deposited. So now we are going to try to understand the last part. If normally Laura is supposed to be the current biggest investor after putting 5.8. I'm going to see if it's going to work right now. So we need to come back to this bank contract, okay, to be able to understand. So we said that the first address was the Alice address. The last one was the Bob address with the malicious contract. Now we're going to select the second address. It's going to represent Laura. Okay, let's come here, Laura. And Laura is going to deposit 5 Ethers. Normally, she's supposed to be the current biggest investor. So if you open this bank again, and we try to be the biggest investor, if you click here, you're going to see the transaction has been reverted. Okay. If we click here, you can see the same address that is actually here, the Bob address. And if you click highest amount, you're going to see 3. While it was supposed to be 5. So this contract has actually break the logic of the bank. And because it has created just a simple function that do not accept, Ether back. So for this logic to work, Bob should get back his 3 ETH so that at least can become the current biggest investors. I hope that was clear, and see you in the next section where we are going to talk about other vulnerabilities around the blockchain space. Yeah, thank you for joining this new lecture and this new session. In this session, we are going to talk about denial of service attack from a practical perspective. In the previous lecture, we saw exactly how this attack can be performed from a theory perspective. Now we're going to go deeper into the code and see how this kind of attack can be performed by an attacker contract. So what do we need to do right now? We need to create two smart contracts. The first smart contract is going to be the bank contract that we talked about, where investors are going to put some money. And the second smart contract that we are going to create is going to be the attacker contract that would try to launch this attack. Okay, so this is actually here. I already created the contract because I don't want to lose or to waste any time. Now I'm going to explain exactly what is actually doing, what is actually doing this contract. Okay, now I've created a file. This file is called the victim.sol. Okay, in the victim.sol, I'm going to write the bank contract that we talked about. Okay, so this is actually the bank contract. It's not too much line of code, so it's going to be easy to understand that. So we already know that we need to specify the license and specify the Solidity programming language version to be able to write smart contract. Now we have our bank. So remember, in the theory part, or in the theoretical part, we talked about a bank. Okay, we said that we have a bank, and the first one to put the money into this bank becomes the current biggest investor, or becomes the most influential investors. So that if Alice comes and deposits 1 Ether, she becomes the most influential investors. But if Bob comes here and deposit, let's say Bob, and deposit 3 Ether, Bob becomes the current king, okay? The current most influential investors. So let's say king. And what is going to happen is that as soon as Bob becomes the current biggest investors, the bank is going to refund, Alice. So Alice is going to take back her money. Okay, so that's actually what we need to understand now. And if someone's, like, let's say Laura comes here and tries to deposit to it, okay, what is going to happen is that since it is not higher than the previous one, than the one that Bob deposited, the smart contract is not going to allow this transaction. It's going to revert that transaction. Let's say revert. Okay, so it's not going to go. So this is actually the principle of this bank. So with that being said, we need to understand exactly what is here. So to do that, we need to declare two functions, or two variables. First of all, the first variable is going to be the current biggest investor. So this is the address of the current biggest investors. So after that, we need to declare another variable that's going to be the highest amount of money that has been deposited by this current biggest investor. So with that being said, we need to continue explaining. There's a function now. Okay, this function is going to be like a button. So once you click that button, you try to become the current biggest investor. So let's say Alice has 1 ETH, okay, and she wants to become the current biggest investor. She's going to click that button. Okay, so this is actually the button that investors are going to try to become the current biggest, okay, around that bank. So what is actually this function is doing? So first of all, this function is checking that the amount of money you want to put inside, okay, this bank is trying to check or to make sure that your amount is higher than what is already inside this smart contract. Let's say Bob is trying to deposit 3 ETH. Okay, Bob has become the king because Alice deposited 1 ETH that is under 3 ETH, or that is less than 3 ETH. Now Laura comes with 2 Ethers, okay, and she tries to deposit. Since the current biggest investor is Bob, the smart contract is going to refuse. So this is actually what this line is doing. It is making sure that the 2 ETH Laura is trying to deposit to become the current biggest investor is higher than the one that Bob deposited. And since it is 3 ETH, the smart contract is not going to allow. So we can actually continue with this function saying that not enough, okay? Not enough fun. So this is the message that's going to pop up, okay, once Laura is going to try to deposit that money into the bank. So now we have another function here. We have another line of code that we need to explain. So once this condition has been met, okay, now we talked about the Bob one. Once Bob has deposited, 3 ETH, okay, he becomes the current biggest investors. What is going to happen is that the smart contract is going to refund Alice her 1 Ether. Okay, this is actually what this line of code doing. So it returns the previous investors. Okay, since Bob has 3 ETH and deposit that money, and Bob has deposited an amount of money that is higher than Alice, and what is going to happen next is that the smart contract is going to give back Alice's Ethers, and the next line is going to say, now Bob becomes the current biggest investor. So this is something that you need to understand. And we're going to try to test the smart contract, and you're going to see what we've been explaining. And then this line of code is actually trying to set the highest amount of money that is actually being deposited so that we can actually see that from the smart contract. So now we are going to try to understand how these things work. So let's come here and run and deploy transaction. We are on victim contract. Okay, this is the file where we wrote our smart contract. So now what we're going to do is that we're going to deploy this smart contract. Let's say deploy. And you see that the transaction has been successfully done. We can open the instance of that contract that has been created. So now we have our function. This is a button, try to become the biggest investor. Okay, this is the function investors are going to click to become the current biggest investor or the most influential investor. So now we're going to try to understand this logic. Okay, let's come here. Let us position ourselves in the first address. So this first account or the first address represents Alice. Okay, so Alice is going to try to become the current biggest investor. So Alice is going to try to deposit 1 Ether. This is Ether, you need to put Ether. And she's going to try to deposit that amount of money and become the current biggest investor. And we're going to click try to become. You see the transaction has been successfully done. And if we click here, you can see that this is the address of Alice. And if we click here, the highest amount of money that has been deposited is actually 1 Ether. So the smart contract is actually doing well because Alice has become the current biggest investor because in the smart contract, there were nothing inside. So the smart contract did not have any amount of money. So the smart contract did have 0 Ether. So that's actually why Alice became the current biggest investor. So this current biggest investor is actually this, variable that we actually declare here. And we also declare the highest amount of money that has been deposited. So these variables are represented by this button. So you need to understand this. When you program a variable and you put the public visibility, we can actually access that variable from the smart contract, from outside the smart contract. So now we are going to try to deposit 3 Ether. Now it's actually Bob. Okay, but before doing that, we need to compare this address and this one that is actually here. So let's come here and copy this one. Let's say copy, okay? And what we are going to try to do is to compare. Since it is Alice, let's do it here. So this is the address that we just copied from here. And now we're going to copy, we're going to position ourselves in the first address and click copy account clip out. And we're going to paste it here to see if it is the same. So you can see that this address and this other one is the same. So Alice is actually the current biggest investor in that bank. So now we are going to try to work with the case of Bob. So Bob is going to represent the second account. So we position ourselves in the second account. Once we position ourselves in the second account, we are going to deposit 3 Ether. Okay. Let's come here. Let's say 3. And then we are going to go down and we are going to click this button that represents the try to become the biggest investor. So Bob is going to try to become the biggest investor with the 3 Ether that he has. So once he clicked here, the transaction has been successfully done. Okay. Now we are going to check if the smart contract is working well. We are going to try to click on the current biggest investor to see the address. You can see the address has changed. And if we click the highest amount of money that has been deposited, now it is 3 Ether. So the smart contract works perfectly. So this address that we have here represents the Bob address that is actually here. So if you copy this one, like we see this with this one, it's going to be the same. So the smart contract is working perfectly. So once Bob becomes the current, biggest investor, the smart contract is going to refund directly, Alice money, Alice 1 Ether. So this is what we need to understand, because you can see that here we have 3 Ether. It means that the 1 Ether that has been deposited by Alice has been refunded. So now we're going to try to deposit 2 Ether now for Laura. Okay. Now for Laura, we're going to see if it works. So Laura is going to represent the third account. So we position ourselves here and we come down here. And Laura is going to deposit 2 Ether. Let's say 2. And we come down and we are going to try to become the current biggest investor with this function. So we are going to click that function, this function. So once we click that function, we see that the transaction has not been successfully done. Okay, you see this red cross. And if we click current biggest investor, you can see it's actually the same address that has been put for Bob. And you can see that it's always 3 Ether. Why? Because 2 Ether is less than 3 Ether. Okay, so this is what you need to understand about this. Now we are going to see how we can break this smart contract. Okay, how we can launch an attack so that it cannot actually work as intended. So this is what we call the denial of service attack that enable the service to run as expected, whether in a smart contract or in other any services. So thank you for joining this course and see you in the next one.